talk. It's my pleasure to introduce Nicole Schneider from Berlin in Germany, from the Charité Dental Medicine department. We met during my appointment at Charité when we were both working at a federated learning solution together with the scientific computing core facility at Charité. Lisa is going to present us, she's a PhD student in this department. She's going to present us a more hands-on experience with one of the frameworks that are commonly advertised or used at the moment, NVIDIA Flare, for federated learning. So I'm very interested to see how far this has gotten and what roadblocks there were and how they may be solvable. Thank you.
Thank you, Alex, for the introduction. I'm really excited to be here tonight and to see all this interesting research you're conducting on federated learning. And yeah, as Alex was saying, I'm a machine learning researcher and PhD student at Charité University Hospital in Berlin. And I was invited here today to share my experience with the federated learning pipeline of NVIDIA, which is called NV Flare. Since I've been working with it since over a year now, I think, and I've definitely found out some pros and cons of this framework that may be relevant for you. And maybe you can already see on my first slide that I'm actually not from the field of neuroscience, but I'm from the dental department. And my department and me, we're researching and developing machine learning algorithms that can be used by dentists to, first of all, provide faster and more accurate diagnosis, but also to improve the patient experience, which is actually quite an important topic in the field of dentistry. And even though neuroscience and dentistry are not so similar disciplines, I think we do have a lot of things in common, especially regarding our data and our model. So for instance, we of course also need diverse data in order to reach model performances and model generalizabilities with clinical accuracies. We also would like to have more data sharing initiatives in order to get more diverse data, but we're of course also strongly regulated by law, for instance, by GDPR. And especially in dentistry, we have big problems as our data is quite sensitive because it's prone to re-identification. As for instance, panoramic images, they carry biometric features which are actually used in forensic work. So you can identify a deceased human being by their dentition in old radiographic images. And therefore, I personally believe that federated learning is a great step forward in order to push AI research in the dental community forward and overcome those problems we have with data sharing. Therefore, we conducted a study in order to convince the research community of the dental space that federated learning is a great method to overcome those problems. And we actually took the tedious path to collect data from 9 institutes worldwide via the WHO initiative AI for Health. And we plan to demonstrate, first of all, the effect of federated learning based on a tooth segmentation task. And the idea was basically to show that for most local participants, it's more beneficial to join a federated learning initiative than relying on their own local training data. And after we set up this first study in the dental space, we faced the question, which tool can we use to actually conduct this study? And therefore, I wrote down a couple of requirements that we had during this research phase. So first of all, it was important that we have some sort of research environment that we can play in, that we can implement the first use case and just see how it reacts to dental data, basically. Ideally, this tool would have the option to directly take whatever we created in the research environment and apply it in a real-world scenario later on with our partners. And in the best case, of course, the tool should also provide the security features that we require to protect our federated learning pipeline with these sensitive data and then the sensitive features later on. Another requirement was that we have an automatic setup, more or less, to set up the clients, set up the communication of server and clients, and that we can basically focus on the machine learning part of this and have a working structure. Then, as I was mainly working by myself on this topic, I chose a tool that has a range of components already provided, like the federated averaging algorithm, for instance, or other components that we can use to deal with, for instance, the problem of data heterogeneity on client sites like Scaffold. But it was also important that we have the option to customize those functions or also to use our own components. And lastly, it was important that we have a high-level dashboard for our non-technical colleagues. So back then, NV Flare seemed for us to be a tool which was most promising to fulfill all these requirements. So let's take a look at how NV Flare is built. So NV Flare is an open source tool provided by NVIDIA. And it has, first of all, it provides management tools for the federated learning pipeline. So it provides a provisioning tool where you can set up clients, you can set up a server, you can monitor them. It provides the whole communication structure between them. And it also provides out-of-the-box workflows for the training of those federated learning projects, their evaluation. We had different learning algorithms and also privacy-preserving algorithms to, for instance, to add differential privacy features. And the good thing was also we could use it on top of our right now, or back then, centralized architectures that we already built with PyTorch, for instance, or Monai. So let's take a look at how NV Flare actually works. So to set up a project, you start off with a project specification, which is basically a YAML file in the end. And there you are defining the identities of the servers, the clients, the admin. You give them roles and rights, and you set up the security that is necessary for your pipeline. Then you can, via an API call to the NV Flare API, you are using the provisioning tool, which will then automatically create startup kits for the different participants. And those startup kits includes the TSL certificates, port numbers for the communication with the server, authentication credentials, roles, rights, and signatures, for instance. And with this, you had the first setup of the federated learning pipeline. So let's take a quick look at how this actually looks like. So here you can see our secure workspace. You can see the local host, which was in this case our server. You can see the JSON file. This is, for instance, the SSL private key in the startup kit, which is also written here. Normally you shouldn't see it, but it's just an example. You have the authorizations of the different clients also included in this. And the same goes for all clients and the admin, for instance. The communication in NV Flare works as follows. You have the server and different clients, and the different clients always ask the server for a certain task. This server assigns the task, the client executes it, and then submits the task result back to the server. The server collects them from the different clients, aggregates them, and then sends them the global model back. This whole communication structure is taken care of by NV Flare and doesn't have to be changed to run the federated learning pipeline. What we as researchers need to focus on is the client configurations and the server configurations. And for the client, this is, for instance, how is the local training conducted? Do we want to apply any filters, for instance, to add differential privacy methods to the results that we are sending back to the server? And for the server, this is how do we want to aggregate those weights? How do we want to evaluate the latest model? And these configurations are defined in JSON files, where we basically have reserved spots where we can add the learner, where we can add different filters. And for this, we can also use the components provided by NV Flare, or we can also add our custom components. So one of those configuration files looks like this. This is a client configuration. We can see here that we, for instance, have the task result filters down here. And here we're adding the differential privacy technique SVT to our model results. And we're defining here that we only want to apply this, for instance, to the training of the model. And this is basically the reserved spot for our task result filters, and then we just add them here. And this is how the configuration file is set up. Later on, we can also see that there's a position for the learner that we can add. And we already see here in this example that the local learner is a custom component that we added, for instance, here. And the custom component in the end is just a Python file that we store under the custom folder and that we can fill with the code that we want for our learners. So for instance, we're adding here the local training, the local validation code, and everything that should be executed at this point. And this is basically all the setup you need to run the first NV Flare pipeline. And then there are basically two options you can use. So first of all, there's this research environment that I was talking about, which allows you to rapid prototype projects or to try out things and develop certain project architectures. And the simulation basically starts clients or creates clients, starts them on separate threads, and then establishes a connection between them and starts the training. And this allows you just to build a pipeline or projects, to debug them, test them, and that you can afterwards directly deploy it in production and the real world use case without changing many of those hyperparameters, for instance. And one feature that I really appreciated was that also in this research environment, it was already possible to use a multi-GPU training, for instance, that if you had one client with a lot of data, you could place it on a different GPU than smaller clients. So this research environment is started with one single bash line. These are parameters that I added to the differential privacy module, but then you can directly see how the different clients are started. They're running up, they're simulated, then they're starting their training. And then these are the warnings that I ignored. Yeah, so here they're calling the data sets, the training starting, and then you can easily stop this research environment with Control-C, and you don't have to shut down 9 or 10 different bash terminals, for instance. There's also, of course, the option to use this in a real-world deployment. We unfortunately couldn't get to this point yet. That's why we're still in the researching phase of the simulation. But the real-world deployment works as follows, that you distribute those startup kits as zip files. Then the local clients, for instance, they can unzip it and then they can start their client via a bash script. And then there's one admin role, and the admin basically operates this whole federated learning round, and they have certain commands, for instance, add a client or remove a client, submit a job. They can check statuses of the clients or the server or the training in general, and this way coordinate the training. And for this, they've also just created an admin dashboard where this can be controlled via an UI. And you can see here, you can download the startup kit and you can create the startup kits. Here you can add new users, and this already gives a high-level overview also to the client side, for instance, to work with this. So generally, as I was saying, there have definitely been pros and cons with working with NVIDIA and with Flare. I've personally liked that it's actively developed, so they're adding new federated learning algorithms. Every couple of weeks, I would say, they create the better management of this platform. And in the latest release, they improved their research setup really drastically. And they also take into account the proposals that people write on GitHub, because I honestly lost a lot of nerves when I started working with this, because there was no research environment at all provided, and you couldn't run 2 federated learning projects at the same time because the communication made problems. And yeah, and I mentioned this on GitHub, and then they changed everything in the new version. There are also many examples on GitHub provided, which is quite good also for different use cases. If you want to add differential privacy, there's an extra example focusing on this, for instance. And so for me, it was actually in the end possible to quite relatively easily transfer my centralized project also to federated learning, to this federated learning paradigm. Of course, the good feature is also the multi-GPU use. And I have to say, in the end, once NV Flare was set up, it also ran quite smoothly. However, you can already hear the keyword once everything is set up, because it was actually, for me, 1 year ago, it was quite hard to get everything set up. And especially since this previous version was not made for research, and there were a lot of things that I had to add manually, basically. And the worst point was basically this debugging was super hard, because you have so many nested functions in the NV Flare framework. So you start in the config file, you then you use different functions, and those functions are nested again. So in the end, if you forget somewhere a bracket, for instance, it was a lot of work to find this point where this bracket was actually missing, because it won't point you to the file where it's actually, where the bug is sitting, basically. Then I was also a bit disappointed that the open source community is quite small. I think, I kind of want to say it's kind of me, myself, and I. There are not too many people working with it. However, the NVIDIA NV Flare team is quite actively on GitHub, and they're replying to questions, and they're helping out to get everything running. So this was, in the end, also good for me, and I could get help from them. And the last point, it was generally, if you want to change something in the components, if you want to bring your own components, that was a really smooth experience. But as soon as you want to implement something or change something that is not on the, that was not planned by NVIDIA, it gets super hard. So for instance, they had this functionality once where they stored the experiments with UUIDs, which was, from a research perspective, not that great, because I rather use like a keyword that I know what is this experiment, for instance, and changing this was, for me, impossible, because the UUID was structured through the whole communication of NV Flare. So, and I think Julian was saying that there's that NV Flare is, the communication is not secure enough for your local hospital. So I think, changing those things will be more difficult. But from the state right now, I'm happy where we are, and it's running smoothly. But as I was saying, it was a quite difficult process as well. So last but not least, I also wanted to show you our results that we got for our first experiment in the dental research community. And here we can see in orange, the federated learning, in blue, the local learning from each center. And we can see that for each participant, the generalizability was better in federated learning with statistical significance. But we can also see that there's still a gap to the centralized performance over here. But I have to say that we did not perform any hyperparameter tuning for any of these methods. So I hope I could give you a little overview of my experience with NV Flare, with the pros and cons, and I'm happy to take any questions.
Thank you so much, Lisa, for this wonderful hands-on talk, how to work with NV Flare as one example of a federated learning framework. Currently, I don't see any messages and questions in the chat. So if you have some, please type one. I already have one. Also, in light of the other talks that we have seen here, now thinking back like 1 or 2 years with your experience of NV Flare and other frameworks that are available, would you choose NVIDIA Flare again, or are you regretting it and say, oh, I should have really used TensorFlow FL, for example, for my work?
Well, that's actually a hard question, because if you haven't, I'm pretty sure that the other frameworks have their flaws as well. And it's quite hard to say if you haven't tested them yet. I would say from the state, how NV Flare was built back then, I probably would have taken a different framework. But at the state where NV Flare is right now, so with the research environment, for instance, I think it's a smooth experience working with NV Flare.
Thank you very much. So